Hello everyone, great to see you. So, did you enjoy the Alibaba Global Mathematics Competition, the qualification round? I hope you enjoy it and you find it interesting because there are many fascinating problems. As a way up who submit a problem to the qualification round, today I would like to share with you the problem I submitted and the answers to the problem. Draw the Joker card. So, have you played the game Draw the Joker card with your friends in your childhood? I guess many of you have played this game because it's quite interesting and it's a very simple game. So let's consider the simplified version. We have two players, A and B, play a game called Draw the Joker card. In the beginning, player A has n different cards, player B has n+1 cards, n of which are the same with the n cards in player A's hand. And the red one is a Joker card. So the Joker card is different from all other n cards. We have three rules as following. The first rule is that player A first draws a card from player B, and then player B draws a card from player A, and then the two players take turns to draw a card from the other player. The second rule is that if the card that one player drew from the other one coincides with one of the cards on his or her own hand, then this player will need to take out these two identical cards and discard them. The third rule is that when there's only one card left, necessarily the Joker card, the player who holds that card loses again. We assume that for each draw, the probability of drawing any of the cards from the other player is the same, which n in the following maximizes player A's chance of winning the game. The first choice is n equals to 31. The second choice is n equals to 32. The third choice is n equals to 999. The fourth choice is n equals to 1000. And the last choice is, for all choices of n, A has the same chance of winning. So, do you have any idea of this question? So, it's mathematics from very simple and common things in our daily life. Let's find the solution to this problem. So first, we may wish to try some simple cases. We denote an to be the probability that A wins a game when A has n cards in the beginning. So for n equals to 1, we have A1 equals to 1/2 plus 1/2 times 1/2 times A1. So the first term, it stands for the situation when A draws the card that is not the Joker card from B. So A wins again. If A draws the Joker card and B draws the Joker card back, then still everything does not change and A has a 1 probability to win the game. So we can solve for A1 as 2/3. If n equals to 2, we have A2 equals to 2/3 plus 1/3 times 1/3 times A2. So the first term is that if A draws the card that is not the Joker card from B, then A wins again, because for the next draw, B will draw the last card from A and discard 2 cards. So A does not have any card in A's hand. So the second term is that if A draws the Joker card and B draws the Joker card back, then nothing has changed. If B does not draw the Joker card back, then B wins the game. So we can solve that A2 equals to 3/4. We may wish to derive the formula for a general AN. Actually, we can obtain the following induction formula. AN equals to n over n plus 1 times A n minus 2 plus 1 over n plus 1 times 1 over n plus 1 times AN plus 1 over n plus 1 times n over n plus 1 times P and n minus 1. We will explain what A and what P and n minus 1 is later. So the first term stands for the situation when A does not draw the joker card from B. So both A and B discard 2 cards after a round. The second term stands for the situation when A draws the joker card from B and then B draws the joker card back from A. The last term stands for the situation when A draws the joker card from B, but B does not draw the joker card back from A. Pn n-1 is the probability for A to win the game when A draws first with n cards including a joker card, and B draws next with n-1 cards that do not include the joker card. So what is Pn n-1? How to calculate it? Actually, we have Pn n-1 equals to 1 minus A n-2, because after A draws a card from B, the card must match one of A's cards in hand, and then the situation is that A will have n-1 cards including the joker card, B will have n-2 cards without the joker card, and B draws first. So Pn n-1 is 1 minus n-2, because now B draws first. Therefore, if we replace Pn n-1 by 1 minus A n-2, then we have this formula. An will be equal to n over n plus 2, A n minus 2 plus 1 over n plus 2. So we can use induction to reduce this subscript n-2 to n-4, n-6, so on. By induction, if n is an odd number, then we have an equals to n plus 3 over 2 times n plus 2. On the other hand, if n is an even number, then by induction we have an equals to n plus 4 over 2 times n plus 2. Therefore, we conclude that A31 equals to 17 over 33, A32 equals to 9 over 17, A999 equals to 501 over 1001, A1000 equals to 251 over 501. So the correct answer is B, and n equals to 32. Initial cards will give A the biggest chance of winning. So, have you got the correct answer? I hope you enjoy the competition, and good luck to your final round. Thank you.